awkward.
Not really. You just like sit there.
No, not like that. But like, it'd be awkward to like have him in the class.
You just like sit there and watch college football. For real?
So the commuter property, all that is with addition and multiplication is that you can jockey your values around. The order doesn't matter, and you still get the same result. Okay. Now I think it's important to really understand a property is to see situations where the property doesn't work or it doesn't exist. Okay. So let's do this. What if I said I'm going to take 7 minus 3. What's that give you? 4. What if I take 3 minus 7? Because all I did is I moved them around, right? Change the order. What's that give me? Negative 4. What's the relationship between negative 4 and 4? They're opposites. They're not the same, right? Okay. So is subtraction commutative?
No.
No, because I don't get the same result. If I'm working through, and there's a lot of things in algebra, guys, that have this property of commutative. There's a lot of things in geometry that have the property of commutative. If I'm able to move things around, change the order that I do something, and I still get the same result both ways, then the commutative property exists for that thing. Okay. The associative property, maybe you've heard in the past, like people explain this because of the root word of associative is associate. Okay? An associate is somebody you hang out with, right? Okay? Now, usually you probably call them your friends. Friends is more of a, or peers is more of like a friendly type word. Okay? It has kind of more emotion to it than saying, this is my associate. Like my wife, that's a little bit more friendly of a word than saying, she's my associate, right? Okay, so it's the same thing, though. That it's who I group myself with. Okay, so when we talk about the associative property of addition and multiplication, it's how you group things together. Well, we use parentheses or brackets to group things together, right? Okay, so all this is talking about is the fact that depending on whether I'm using addition or multiplication, if I change the groupings and still get the same results, then the associative property is existing. Okay, so let's do this idea here. What the associative property of addition says, if I go A plus B plus C, but I group together these two first, that will be the same thing as A plus B plus C by grouping those two first. Okay, I'm going to give you a specific example here. If we have, let's just say A is 2, let's say B is 3, and C is 4. If I group them this way, what's 2 plus 3? 5 plus 4 is 9, right? That's going to give you 9 as an answer. Well, what if I did it this way? 2 plus 3 plus 4. What if I added those two together first? 3 plus 4 gives me 7 in this case, right? Because the order of operations tells me to do 3 plus 4 first, right? So I get 7, but then when I add 2, what do I get? 9. I get my 9 again. I get the same result, correct? So the associative property allows me to group them that way, okay? Now, the reason we use the associative property most of the time is, for instance, what if I had something like this? So if I say, I've got 7 plus 4 plus 3. Okay? A lot of times what we'll do is we'll first use the commutative property. We'll take that number and we'll move it there. So we'll go 4 plus 7 plus 3. Because we know we're allowed to do that, right? And then we'll group those two. And why would we group those two? That's an easy addition, isn't it? Yeah. Okay? 7 plus 3 easily gives me 10. Probably maybe easier than adding 7 and 4 does. Now, we should all be able to do either of those, but that's one of the purposes of using the commutative property and associative property together, is because they will allow us to maybe do mental math a little bit quicker and a little bit easier. Okay? And then the structure of these properties allow then for other properties to be generated. Let's talk about the multiplication one. Okay? Same idea. if I start with A times B, I do that multiplication first, and then finish it by multiplying by C. That should be the same thing as first multiplying B and C together, and then multiplying that by A. Okay? So let's use the same values here of 2, 3, and 4. I go 2 times 3 times 4. What's 2 times 3 give me? 6. What's times 4 then going to give me? 24. Okay? Well, if I grouped it this way, what's 3 times 4 going to give me? And then double that, still 24, right? So those are the associative properties of addition and multiplication. All right? It is something that maybe in the past you've talked about it for a couple days, and then you move on and you don't talk about it. And then when I ask you, well, what property is it that allows you to move things around? And everybody answers, it's either the associative or community. I can never remember. We will continually use those phrases so that it is ingrained in your mind which one's which, because they allow for so many other properties to kind of build off of. Okay? All right, so we'll finish out this side of the page going through this set of properties. This stuff should be easy. Okay? The one word here that I like to kind of draw our attention to is the word identity. Okay? You all have an identity, right? Okay? And it is very, very, very difficult to change that identity. Okay? So we're going to say that our identity, for all intents and purposes, is unchangeable. Okay? Let's think about some numbers. Okay? So your identity is you, right? You're the person. If I say 7, that's 7's identity. What it looks like is its identity. Does that make sense? Okay? 7, we can change it. Okay? But what do we add to 7 so that we don't change it? 0. Okay? So whenever you add something to a value and you don't change it, we are adding what we call the additive identity. Okay? So 0 is the number that we add to anything and don't change it. That's obviously something we've known, right? Okay? But the additive identity, okay, right here with addition, says A plus 0 is just going to give me A. It is unchanged. Okay? That's pretty simple to think about, right? These properties here should be simple all by themselves to think about. But again, they are the building blocks for very complex algebra systems later on. Okay? So A plus 0 is equal to A. Examples of that, obviously like 3 plus 0 equals 3. If I want to say 2x plus 0 is going to equal 2x, right? Okay? So those are some examples of that. If I'm going to multiply, let's say I start with 7. I can change that identity by multiplying by 2, 3, 4, negative 1, negative 2, negative 3, negative 4. But what is the one value I can take any number I want to and multiply it and not change it? Careful. Start with, okay, it's 1. Okay? So I'm going to multiply by 1. Okay? And my value that I started with is unchanged. Take any number you can ever imagine, multiply by 1, you still get that number that you started with. Okay? It's unchanged. So, if I'm going like 12 times 1, that's 12. Maybe 4x times 1 is going to give me 4x. Okay. A lot of times, I think we're working through something, and I need to add 0 to it. Do we ever really do that? No. Okay? Because I'm going to get what I started with. I usually, working through something, I'll never multiply it by 1 in that version because it doesn't change it. Okay? Now, there are times I want to multiply by 1, but I won't do it in that version. Maybe I want to multiply by 2 over 2. That's a version of 1. Does that make sense? Okay? And that would change my 4x to 8x over 2, which would change the looks of it. Does that make sense? I'm still multiplying by 1. And those are things we'll talk about in the future. What do I multiply by so that I get a product that is 0? 0. So take any number, multiply by 0, you get 0. Okay? So if I start with 5, multiply by 0, I get 0. If I have 7x, multiply by 0, I get 0. That's actually one of the we'll talk about solving towards the end of the year. A type of an equation that will actually be one of the most used equations that you see in your next class, in the following class, and the following class. And the number one reason why we're allowed to solve that equation is that rule right there. Okay? So when I take two numbers and multiply them together, and I get 0, and doesn't that mean that one of them had to be 0? That makes sense? Okay? And then the multiplication property of -1 says if you start with any number and you multiply by -1, you are going to get the opposite of that number. Does that make sense? Okay. Now, I don't like to think about this as like I'm going to start with a positive number, multiply by -1, and I get the negative a. Does that make sense? When I see this right here, when I see that right there, and I come back up here and it said let a be any real number, my a could be negative. Does that make sense? So let's say a was -5, and I multiply by -1. What does that turn into? +5, right? Okay. Well, I look at +5. It doesn't have a minus sign in front of it like this does it? Okay. So what we're looking at here is that we read this as the opposite of a. Because what if a started negative? Does that make sense? Okay. And we should obviously know the opposite of a negative, then it's positive. Okay. So if we're doing some examples of that, let's say a is positive. We go 2 times -1. Obviously, it gives me the opposite of 2. If I do -5 times -1, that's going to obviously give me the opposite of -5, which is 5, right? The main place that we'll use this is if I have like -x. If I multiply -x by -1, what's that going to give me? Positive x. Okay? And in a lot of the equations that we'll get to in the future, we want to solve for positive x. Okay? Is that okay with everybody? That stuff pretty straightforward? Okay? What I want to do for the remaining time, I need you guys to log into Math Excel real quick.